Hey solar nerds, what's going on? So I wanted to give you an update on how things are going with our installed solar stuff. They did finally put in the battery box here. So it's got all the batteries safely stored inside. The main purpose of this is just to keep things from crossing the terminals and shorting things out, causing all the magic smoke to come out, which is a bad thing. So mostly just to keep the batteries themselves safe from things accidentally hitting it. They did install the gas vent. Because these are lead acid batteries, when they're being charged, especially at a very high rate, they produce hydrogen sulfide gas. I think it's hydrogen sulfide. And so as it outgasses, it gets trapped in this cabinet, and then there's a fan which kicks in. The fan's actually installed up there, and it pulls the gases out and vents them outside where they can dissipate safely. The gas itself isn't really especially harmful. In small quantities, it's a nuisance odor, but when it gets in high quantities, it can be explosive. And so when you've got electronics and hydrogen sulfide gas built up, it can cause issues. And the fan is controlled by, I think, this. Yeah, I'm pretty sure that's correct. So whenever it detects that the battery voltage is sufficiently high, it turns on that fan. So when the voltage drops to a more nominal value, like at night, then the fan cuts off. So we're producing a lot of energy. We're reaching the point where both inverters kick on before noon. It usually happens when this inverter gets up to about 6.4 or 6.5 kilowatt hours. Then it'll tell the secondary one to turn on. So it goes out of pass-through mode, and then they both start pulling excess power from the batteries and producing it out to the grid. So the solar panels here, these are the chargers. We're producing a lot of power. This is pretty astonishing. So far today, and this is just for this morning, it's a bright sunny day. Almost 13 kilowatt hours total. So this one, which is 9 of the roof panels, is producing quite a lot of power. And it's not at peak. It reaches peak power approximately around 2 p.m. or so, maybe 1:30. And then the sun starts to set, becomes a more oblique angle, and the power starts to go down. So each of these is receiving and putting out quite a lot of power. 1.7 kilowatts, it's pretty good. The roof array, so the roof array should have less power coming in, generally speaking, because it's a little bit flatter relative to the angle of the sun. So during the summertime, these deck arrays, the deck arrays will produce a lot more power than the roof arrays will. So this guy's putting out, he's getting 1.7. This guy's getting 1.5. It's actually pretty good. They're fairly close. So that's where we are. And in terms of total power, see if I can get it to focus here. Come on. Focus. There we go. So in terms of total power, you can see that the load, which is what the house is consuming, right now it's a little over 500 watts, and we're producing almost 6 kilowatts. So we're producing 10 times more than what we're consuming. Now, of course, if we run something like we start pumping water, or in the summertime we'll have the pool pump running, we turn on the dishwasher, things like that will consume more energy. But on a typical day, especially when we're both at work, we use almost no power at all and produce quite a lot. And that's actually not optimal in terms of saving money on electricity. And the reason for that is because our meter doesn't actually run in both directions. What happens is it tracks how much energy we pull from the grid at night, and it charges us about 8.5 cents per kilowatt hour. But then in the daytime, when we're producing energy and selling it to the grid, they keep track of that separately. And so they pay us about 4.5 cents per kilowatt hour. So they're only paying us half of what we pay them, and it doesn't sort of balance out to where, if we use a kilowatt and then we produce a kilowatt, the net is zero. It doesn't work that way. We pay them 8 cents per kilowatt, they pay us 4 cents per kilowatt, and so you just do the math on the bill. So it's much better for us to use the energy that we're producing. So this has caused us to look into some of the fancier features of some of our appliances. So for example, our dishwasher has a delay start feature. And so we typically start the dishwasher around noon when we're producing peak power. That way we're using our solar energy that we produce to run the dishwasher, the water heater, and the pump, rather than doing it at night where we're only buying that energy from the power company. And likewise, our clothes washer has a delay start feature. Unfortunately, our clothes dryer does not have a delay start. So we kind of have to either do that on the weekend, or as soon as we get home before the sun starts, we start it. So there's little things like that that you can do to help make sure that you're using the energy you produce rather than sort of just selling all that energy to the grid at a lower price and then buying more back when you do stuff like that at night. So hopefully this has been a little bit educational, and that's where things are. They've done a little bit of tidying. I'm not 100% thrilled with how this ducting is done. I think that could have been done more cleanly, but overall, I think down here is pretty well, quote unquote, done. There's still some more work that needs to be done out on the deck, and maybe I'll cover that in a future video. So anyway, enjoy, and talk to you guys later.